Today, we're going to add underwater caustic patterns to our water in Unreal and Unity. Let's go! For the last couple of weeks, we've been working on this water shader. We've got waves, surface ripples, refraction, and then last week we added this foam to the surface as well. Some of you asked in the comments how we could create underwater caustic patterns, and so that's what we're going to do today. So here's what they look like, and if I toggle them on and off, you can see this is without the caustic patterns, and then this is with them. So what exactly is going on here? Well, caustic patterns happen when the sun shines through the water, and because the water's surface is rippling, the sunlight gets focused and bent, just like it does if you hold up a magnifying glass and see the sun shining through it on the ground. The water is acting as the magnifying glass here, but because the surface is rippling and waving, the water has these really interesting looking rippling caustic patterns. So we need to create this effect in such a way that it can be projected and look like the light is shining through the water and being focused underneath. So what we're going to use today to create these caustic patterns is called a decal. And what a decal is, let me just turn off the caustic patterns for now. And I'm going to turn on this example decal that I have here. You can see I've got this nice little vase of flowers projected on the bottom of my pool. So what a decal is it's just a box. So you can see I've got this three-dimensional box, and there's this nice white arrow here indicating the direction of projection. And so what's happening is my flower texture is being projected into my scene inside the box. So anywhere where this box projects, or anywhere where this box intersects meshes in the scene, they're going to receive this particular flower texture. And I can create a shader that gets applied anywhere where the box intersects with the scene. So for example, if I move the box up here onto this rock, you can see now my decal's getting projected onto the rock. And basically anything that's inside this box is going to have that flower texture projected on it. Well, let's take a look at the shader that we've created for this decal. So here is my very simple decal shader. You can see I've just got one texture sample here, and it's plugged into base color. And if I switch over here to my graph settings, you can see that my material type is set to decal, and I have it set to affect base color. That means whatever's coming into this base color pin is what's going to be projected, and it's going to be projected into the base color of my scene. So if I switch back to my scene here, let's open up the analysis rendering debugger and take a look at our materials. So if we look at the albedo of our scene, you can see that the flower vase is being projected into the albedo. But if we switch this to something like smoothness, you can see it doesn't affect the smoothness, it doesn't affect the normal, it doesn't affect the ambient occlusion. It's only being projected into the albedo. And that's because I have the decal here, the decal shader, set to affect base color. I could also project into the normal, the metal, the ambient occlusion. I can choose what I want the decal to project into, and in this case we're just projecting into base color. However, in the case of caustics patterns, caustics are light, and light is emissive. So we don't want to project our caustics into the base color. Instead, we want to affect emission. And so I'm going to check that box. And now I'm going to wire instead of wiring into base color here, I'm going to wire this into the emission pin, and I'm just going to delete all these other inputs. We don't need ambient occlusion, metallic. We don't need any of these. We only need emission because we're projecting into the emission of the scene. Now, I probably don't want this vase as my caustics patterns, so I need to grab a caustics texture. Let's go ahead and grab this caustics texture that I made. Here you can see my caustics texture. Let's just take a look at this. Right, so you can see I've got this caustics texture here, and I've generated this with a piece of software called Caustics Generator, and I'll link that down in the description. And then after I generated it, I created a little bit of chromatic aberration by offsetting the blue channel up and to the left and the red channel down and to the right just by 1 pixel. And you can see that creates this kind of rainbow fringing, which is kind of a simulation of the light being split and scattered by the refraction of the surface of the water. So this is a tiling texture, and you can see here I'm just passing it into emission. And let's go ahead and save this and see what our decal looks like now in the scene. All right, so here's our decal, and you can see that it's almost completely invisible. And the reason for that is that in HDRP, emission uses a crazy scale. It's like you have to have these really high values because it's actually using like lumens or something like that, like the correct measurement of light for emission. And so in order to get this emission to show up, what I need to do is take my color value that's coming out of here and multiply it by a really high number. So I'm just going to multiply this by, let's say, 50,000. And now we can pass this into our emission pin, and I'll save it. Switch back to our scene. Yeah, and now you can see I've got my caustics pattern projected into my scene. All right, now the next thing that we need to do is actually project it. What's happening right now is I'm using the UV coordinates of my decal. So you can see I've got UV0 coming in here, and basically what that does is it maps this texture to the 0 to 1 range of the dimensions of the box. And so you can see, actually, let's move the decal over here to the ground so it's a little bit easier to tell. So my texture is being projected here in the dimensions of the box. But what I want to do is project it in world space. So right now, if I move my box around, you can see that my caustic pattern is going with the box. And what I actually want to do is have the caustic pattern stay in the world. So when I move the box around, the caustic pattern stays put. And so what I'm going to do is I'm going to bring in the position, and this is the position in world space. And I need to use a swizzle node here to just take the X and Z coordinates. So I'm projecting top down. So I'll take the X and Z coordinates in world space, and I can use these for my projection coordinates. All right, so let's take a look at what we get from that. All right, so it looks pretty similar to the way that it did before, but now when I move my decal around, you can see that because I'm projecting in world space, the caustic pattern is staying put, and I'm just revealing different parts of it by moving the decal around. So I've got my projection happening in world space. The next thing that I need to do to create my caustic pattern is scroll this. So in order to scroll this, I need to bring in a time node, and just like I always do, I'm going to multiply my time by a constant value. So I'm going to bring in a vector 2, and let's multiply this by 0.6 and 0.3. These will be the speeds that I'm scrolling my decal texture. So all I need to do is add time to my texture values here, and then wire them into the UV coordinates on my texture sample. And there we go. We got scrolling coordinates on our caustics. Now I do want to adjust the scale on these just a little bit. So I'm going to come back to my shader and I'm going to add a multiply here. And we're going to multiply this by 0.3 and then pass the results in. And yeah, so now I have some scrolling values. Now, one thing that you might notice is that my decal projector here is kind of small. So let's take a look at what we can do to improve that. If I come over here to my inspector, you can see I have a couple of different ways of adjusting my caustic volume. And I'm going to use this icon here in the middle. And what it says is modifies the projector boundaries and crops and tiles the decal to fill them. So if I hit this button, what you can see is now I've got these little manipulator handles on my box. And I can just grab this handle and stretch it, and it changes the dimensions of the box. So I'm able to change what my decal is being projected on and how big it is interactively in the scene. Just by grabbing these handles, I can make the decal project a little bit higher, I can make it project lower, and I can expand the boundaries of my decal. Alright, so let's take a look at what we have here. The next thing I think that we need, so we've got our scrolling texture, but it's scrolling really uniformly. And what I'd like to do is make it kind of undulate a little bit, kind of like the surface of our water. Our water surface is kind of scrolling in a really non-uniform way. And I want to kind of break up the UV coordinates on my decal here so that I get a little bit of non-uniform scrolling instead of it scrolling all as one unit. So let's switch back to our shader. And I'm just going to clean things up here just a little bit before we continue. All right, there we go. So the next thing that I'm going to do is add another sample texture. And we're going to sample a normal map that we're going to use to distort the UV coordinates so that when our texture scrolls, it scrolls a little bit less uniformly. And the normal map I'm going to use in this case is called Puddle Norm. And let's just take a look at this texture. So here's my Puddle Norm texture. And one thing to note about this is I'm not storing it as a type normal map. And because of that, I need to make sure when I sample this texture in my shader that I go ahead and expand the values to the -1 to 1 range. So I'm going to take my normal map here, and I just need the X and the Y of the normal. And so I'm going to add a swizzle node and just grab X and Y. And then I'm going to multiply by 2 and subtract 1. So multiply by 2 and subtract 1, and we're good to go. So there is my normal, and I'm going to use these values here to offset the coordinates that I'm using to sample the caustic scrolling. And so what I need to do is take this result and add it right here to my texture coordinates before I use them to sample my caustics. All right, so now I can take my normal map here and I can use it to distort my caustics patterns. Now, you might have noticed that it's distorting it an incredible amount, and that's because I'm offsetting these UV coordinates a lot. And so what I need to do is tone this down a little bit. I'm just going to add a multiply here, and we're going to multiply this by 0.05. We're going to tone it down a significant amount. And then after we tone it down, okay, now you can see we're getting a little bit better result here. Our distortion is not quite as strong. All right, let's go ahead and save this and take a look at our result. Okay, so now you can see that our caustics are getting distorted. I might play around just a little bit with the amount of distortion here, because that still feels like quite a bit. Actually, you know what we need to do? We need to scroll our distortion texture just like we're scrolling our caustics texture. So I'm going to grab my time node here. And again, we're going to add another multiply to control the speed that we're scrolling time. And we're going to scroll it 0 in the X and 0.3 in the Y. So let's plug this in. And now we're going to grab our position here that we're projecting. And I'm going to scale it down just a little. So I'm going to, or actually scale it up just a little. I'm going to multiply it by 0.4. And then we're going to add our time to it. So this is the world wipe down projection that we're using. I scale that just a little bit, and then I add our time to it. And now I can use this as the coordinate that we're going to use to scroll our normal map here to then distort the coordinates that we're going to use for our caustics texture. All right, there we go. So we're scrolling the caustics texture in one direction. We're scrolling the distortion texture in another direction. And that distortion normal map that you can see over here on the right is distorting the UVs and giving us a kind of a nice warping effect. All right, the next thing that we need to do is I would prefer to have two caustics textures that are scrolling across each other, because even though we are getting some distortion here, it still looks fairly uniform the way this texture is scrolling. And so what I want to do, so first of all, we're just going to clean this up just a little bit. And then I can just take all of these nodes here and duplicate them so that we have a second set of scrolling textures. So I'm going to copy and paste. And now I've got my second set of scrolling textures here. I do want them to scroll in a different direction. And so I'm going to take this value over here that I'm using to scale the coordinates, or that I'm using actually to control the speed. And I'm going to negate these values here so that this version is going to scroll in a different direction. So I need to come and grab my time over here and multiply my vector 2 here by time. Then I'm going to add that to the world position that I'm using. Then we're going to scale it. Here we're scaling by 0.3. And I think I'm going to change this just a little bit. Instead of 0.3, it's going to be 0.33. This will just give like a subtle difference to this version. Okay, and then I can take the result coming out of my texture here and just add it together with my other scrolling texture, and then pass that into my multiply where I crank up the value for my emissive there. All right, so let's take a look at what we get. Okay, so this is really nice. I've got a kind of chaotic looking caustic pattern here with the two scrolling textures, both of which are getting warped by that third scrolling normal map. There is still a problem here. This is looking pretty nice, and it might work if all I was going to do is add caustics to the bottom of the pool. But I actually want to do more than that. If I move this caustic decal over just a little bit and intersect it with this rock, you can see a good illustration of the problem that I still have. The caustics are being projected on this world Y axis, and anywhere they run into something that's vertical, a vertical surface like this rock here, they're going to get stretched. It's probably going to be even more evident if I move it over here and intersect it with the wall. So this no longer really looks like a caustic pattern at all. Because it's being projected from the top down, it's just getting smeared down the side of the wall. So what I really want to do is project this decal in all three axes. So instead of just projecting it from the top down, I want to project it from the top, front, and sides. So the next thing that we're going to do is take a look at how to change this decal. So instead of just top-down projection, I can actually project it along all three axes. So let's switch back to our shader. And so here's where our projection is happening. We have position, and we're taking the X and Z components of the position to project it in the Y axis. So what I'm going to do is duplicate this swizzle node here, and we're going to project it in the X axis by taking the Y and the Z components, and we're going to project it in the Z axis by taking the X and the Y components. So here are the three different projections of my world position that I want. And now what I can do is just lerp between these. So I'm going to blend between the X projection and the Y projection. And then I'm going to lerp between this and the Z projection. And now the question is, what values do I need to use in order to lerp between these projections? I need a T value here for my lerps. And there are two different options that I have. What I want to do is lerp between these based on the normal, the angle of the surface that I'm intersecting. So if it's pointing up, I want to use the Y projection. If it's pointing to the right or left, I want to use the X projection. And if it's pointing front or back, I want to use the Z projection. And so in order to figure out what direction the surface is facing, I need the world space normals of the scene. And in HDRP, I can bring in this node called HD sample buffer. And there's a bunch of different buffers that I can sample, but I want this world normal space buffer. And I want to turn these into masks so that I'm masking out the direction that the surface is facing. And so what I'm going to do, I don't need negative values. And so I'm going to add an absolute node here so that negative values become positive. And then I'm going to add a round node so that I round up either to 1 or to 0. And now what I've got is the answer to the question, is this facing up? Is this facing right or left? Is this facing up or down? And so I can split this out. And so my red channel here is determining if it's facing right or left. That's the x-axis. My green channel here is determining if it's facing up or down. And my blue channel is determining if it's facing left or right. So if it's facing up or down, this one is going to be true here. So I can use that to blend between my X projection and my Y projection. And then if it's facing front or back, this one is true. So I can use that to blend between this one and my Z projection. So now I have a set of UV coordinates that changes depending on the direction that the surface is facing. So let's go ahead and instead of using just my Y projection, now I can use the projection that I'm getting where I'm blending all three of those. So let's go ahead and plug this into my first scrolling caustics texture, and we can plug this into our warping texture, and we can also use these coordinates for the second scrolling caustics texture. And let's save this and take a look at what we get. Okay, so just like we had before, our texture is being projected from the top down. But if we slide over here to our rock, now you can see that wherever it's intersecting the rock, it's also being projected from the front and the sides. And if we slide it over here to the wall, now you can see that when we intersect the wall, we're using the X projection instead of the Y projection, so it's no longer smearing. And basically, wherever we project this decal, because it's being projected along all three axes, we're going to get it looking nice from the top down and nice from the sides as well. So now we have a decal that can project wherever we set it. And so now all that remains to be done is to scale our decal up so that it fits our entire body of water. And we've already done that with our other decals, so I can just unhide that one. All right, now you may notice that there are two problems with this projected decal. The first problem is in areas where our normal is changing really fast, we get a lot of noise. I don't know if you can see this very well, but there's like a ton of noise, and that's because our projection is blending between top, left, and right, and front and back really quickly, and we get these kind of ugly borders between the areas where the projections are changing. You can see that there's kind of a lot of pixelated noise here. So that's one problem. And then there's another problem here where we've got this hard edge along the border where our projected decal ends. And those are the two issues that we're going to talk about next week. So next week I'm going to talk about how to improve our Caustics shader by getting rid of this pixelated noise, and also how to soften up the edge of the decal so that it's not such a hard, harsh termination there at the borders of the decal. But I would say overall, this is looking pretty cool. If we look down into our water here, you can see that the Caustics pattern adds a lot to the realism of the water. If we toggle it on and off, you can see without it, it just doesn't look quite as nice. All right, so that's our tutorial today. Now we're going to switch over to Unreal, and I'm going to show you how to do the same thing there. All right, here we are in Unreal. And just like we just did in Unity, in Unreal, we also have a Caustics decal in our water pool. You can see I've got this object selected here, and I can move this decal around. As I move it outside of our pool, you can see over here in this area, I no longer have my Caustics projected. But then inside this decal box, I've got my Caustics over here. And I can even intersect them with my rock objects over here if I want to. Now you can see I've got the Caustics projected on these rocks. So basically this decal is working just the same way that the decals that we just looked at in Unity are working, where whatever objects are intersecting this volume here, this box, I'm going to be projecting our caustic patterns onto. Now, one thing that I need to point out is I already created a tutorial video a couple of years ago where I showed how to do this in Unreal. And so I'm not going to get quite as in-depth with this explanation as I did in Unity, because you can always just go back and watch that previous video where I showed exactly how to do this in Unreal. And I'll link it in the description down below, along with the textures that I'm using for this caustic effect. So yeah, be sure to take a look at that down in the description. All right, so let's take a look at the shader that we're applying to our decal, or the material here that we're using on our decal. So here's our water caustics decal shader. I'll just kind of zoom out so you can see the whole thing. The first thing that I want to point out is over here on my root node, I've set the material domain to deferred decal and the blend mode to translucent. Now the only thing that we're actually going to be using today is the emissive color. We don't need base color, metallic, roughness, any of these. We just need the emissive color because, like I said before, this caustic pattern is light and it's just projecting illumination basically. And so we don't need to change the base color of the objects in the scene. We just need to project the decal pattern onto them. So let's take a look at how this is constructed. I've got my texture sample here, and we're sampling our caustics texture. We take a look at our caustics texture. I'm going to turn off the alpha channel. There we go. So that's what our caustics texture looks like. And it's just basically made to mimic the appearance of projected caustics. And I made this with a piece of software called Caustics Generator, which I'll also link down in the description. And then I've offset the pixels up and to the left for the blue channel and down and to the right for the red channel which is what creates this kind of color separation called chromatic aberration. All right, so I'm taking that texture and scrolling it. And if we move over here, we can see how that scrolling is done. I have a panner, and my panning speed here is 0.3 and 0.15. And then I'm multiplying that times this multiply, which is multiplied by 0.6. That just kind of scales my coordinates down. But here I'm also multiplying this by a global multiplier here, which is 0.5. Now, if I wanted to, I could optimize this just a little bit by just pre-applying this 0.5 here to these multiply values. And in fact, I think I'm going to go ahead and do that. So I'm just going to set this to 0.33 and wire this in directly. I'm going to set this to 0.3 and wire that in directly. Then I'm just going to get rid of this multiplier completely because that just becomes 1. I'm going to delete these nodes here. And there we go. So that gives me the same result. Okay, you can see that I've got my panner here, which is scrolling, and I've defined my scrolling speed. And then I've got another texture down here basically doing the same thing. I have a panner with the scrolling speed, and you can see I have a negate value here, which is changing the direction of scrolling. So you can see this texture is kind of scrolling down and to the right, and this texture is scrolling up and to the right. And then I take these two texture samples and add them together. And here I'm multiplying by 2, but this value, you can use whatever you want for that, depending on how bright you want the caustics to be and how prominent you want them to stick out in the scene. I've multiplied them by 2 for now so that they're more obvious in the scene here. But like I said, you can control this value and set that to what you'd like it to be. All right, the other significant thing that I'm doing here is I'm warping my texture coordinates. And you can see that I have this add node here where the texture coordinates that are being generated by my panner, I'm adding to them a little bit of offset that's being created by this normal map here. So here is my warping normal map, and I'm using this to distort the UV coordinates that I'm passing in, so that instead of scrolling uniformly, my values are kind of undulating and getting warped by this scrolling normal map. So I also have a panner on this normal map, and you can see that I'm just scrolling it in the Y dimension by adding a 0 in the X and a 0.3 in the Y to scroll my distortion normal map there. Now, if I were to just pass this in as it is, it would distort it way too much. And so I have to multiply it here by this value 0.015 to tone it down quite a bit. You can see that it's like really dark there after I multiply it. And then I just isolate the red and the green channels of the normal map because that's what I'm using to distort. So once I've sampled my scrolling normal map here, I can just add those values to my UV coordinates and then use those coordinates to sample my caustic textures here. All right, and then the last thing that I'm doing here is projecting in all 3 axes. I've got my absolute world position here, and I'm multiplying it by negative 0.01 just to scale it up significantly. This basically makes the world position units in meters instead of centimeters, which is what Unreal does by default. All right, so I take my absolute world position and then I isolate it into its the X projection, which is the green and the blue, the Y projection, which is the red and the blue, and the Z projection, which is the red and the green. So I have these 3 projections. I'm projecting in the X direction, the Y projection, and the Z projection direction. And then I have to blend between them. So I'm using these lerp nodes to blend between these 3 different projection directions using the normal of the world. So I have this node here called scene texture, and you can see here over here I have it set to world normal. This is bringing in the normals of the world, and I use that to determine which of the 3 projections to use. So I'm going to take my scene texture world normal, and then I'm going to use an absolute value on it so that negatives become positives, and then I'm going to round it to the nearest 0 or 1. And basically what these 3 nodes together give me are 3 different answers to the question, am I facing up and down? Am I facing front and back? And am I facing left and right? And so in order to blend between my 3 different sets of projection coordinates, I use the green channel of my world normals here, and I use the blue channel of my world normals. So I'm blending between X and Y using the green channel, and I'm blending between that and Z using the blue channel. And what this gives me is a set of texture coordinates that's projected in the front and back, left and right, or top and bottom, depending on which way the surface is facing that's intersecting my decal projection volume. And then I just pass those coordinates into the panners for my first Caustics texture, my second Caustics texture, and also my texture coordinate warping scrolling normal map. All right, so I'm able to project my Caustics pattern in all 3 axes of my decal using these nodes here. And then I pass those coordinates into the panners, including the normal map here, so that I can warp my UV coordinates so that I can get some nice warped caustic patterns. All right, so that is my caustic shader or material in Unreal. And you can see that when I apply it to the decal, I get some really nice looking projected caustic patterns under the water. And wherever I put this decal is where those caustics patterns are going to be projected. So that's pretty cool. It adds a really nice bit of realism to the portion of the water that's underneath the surface. And I really like how that turned out. Okay, I hope you enjoyed today's tutorial. Be sure to come back next week. We're going to talk about how to get rid of these really weird looking artifacts here that happen when the surface normal shifts quickly between different facing directions. And we're going to also talk about how to fade out the caustics patterns at the edges of the decals. So be sure to come back for that. And in the meantime, have a great week, everybody.